This is question about monoid. Is identity element unique? This is the question number 1. What can you say? Is identity element unique in monoid? Yes. Remember, identity element is always unique in every structure. Okay, in every structure, identity element is at most 1. So this okay, this you already know, right? Correct. So identity element, okay, in any structure there is at most one identity element in any structure. Okay, whatever structure you take, in any structure, whatever structure you take, okay, there is at most one identity element. There is at most one identity element. We can never have more than one identity element. So that's the idea. Okay, in any structure, whatever structure you take, so you will always have unique identity. So because it is monoid, so in a monoid you have at least one identity element, right? Because it is monoid automatically has, monoid is semi group with identity element. What is monoid? Monoid is semi group with the identity element. So in a monoid you have identity element. Okay, so I can say yes, identity element is unique. What about this? Do we have left cancellation property in monoid? Left cancellation means what? What is this property? This property is like this. If you have a hash b, this is equal to a hash c. If then can we cancel? Then can we cancel this? This is the left cancellation property. Left cancellation property that can we cancel this? So a hash b is equal to a hash c. Then can I say b is equal to c? Can I say b is equal to c? Means can I cancel this left? Left cancellation means on left can I cancel. Right cancellation means on right can I cancel. Can I cancel on right? Right cancellation is like this. This type of thing is right cancellation. So let's assume you have this type of thing. Then can I cancel on right? Means on both sides can I cancel on right? Okay. So this property is called right cancellation. In a monoid, do we have left cancellation property? In a monoid, can I say? Tell me. So in a monoid, we don't have left cancellation, right cancellation property. Okay, we don't have left right cancellation, left comma right cancellation property. Okay, what it means, see, if I give you one example, basically, okay, just take this example. Is this a monoid? Set of natural number comma star, and let's assume that your operation is a star b is equal to max of a comma b. Is this a monoid? Tell me, is this one a monoid? This structure, is this structure a monoid? Yes, this structure is clearly a monoid, because what is the identity element? The identity element is 1. Okay, so this structure is monoid. But now notice that in this structure, tell me, can I say, okay, this is my question. Okay, can I say that if a star b is equal to a star c, then b equal to c? Can I say? This is known as, remember, this is known as left cancellation property. This is known as left cancellation property. This is known as left cancellation property. Basically, can we do the cancellation on the left? Can we do cancellation on the left? See, this a is on the left, a is on the left. Can we do cancellation on the left? Is this statement true? Can anyone give a counter example? Anyone want to give a counter example? Can I say in this structure, this is a monoid. Can I say in this structure, if a star b is equal to a star c, then can I say b equal to c? The answer is no. The answer is no. Why? Because you can very clearly see that, for example, 3 star 1 is equal to 3 star 2, right? Yes or no? Agree? 3 star 1 is also 3, and 3 star 2 is also 3. So 3 star 1 is equal to 3 star 2, but you can notice that 2 is not equal to 1, but 1 is not equal to 2. So we cannot do left cancellation, right? Agree? So in the monoid, we cannot do left cancellation. So that's the point. Similarly, I can say, similarly, you can do for right cancellation. Right cancellation also we cannot do. left cancellation is not there. Okay, similarly you can do the right cancellation example also you can do. So for example, tell me 1 star 3 is equal to 2 star 3, right, correct, because 1 star 3 is also 3 and 2 star 3 is also 3. But you can notice that you cannot do the right cancellation, you cannot do right cancellation, so 1 is not equal to 3. So the idea is very simple. So in monoid we don't have left cancellation right cancellation property. Okay, in monoid we don't have left cancellation right cancellation, left cancellation and right cancellation property. Anyone has any doubt in this? So in a monoid you cannot do left cancellation right cancellation. This is what you cannot do. Anyone has any doubt in this? Is this question clear to everyone? So okay, do we have left cancellation property? Do we have right cancellation property in monoid? The answer is no. Let's come back to this question. Is this a monoid? Integers comma multiplication. Integers comma multiplication. Yes, this is a monoid, right? Yes, clearly this is a monoid because you have identity element as 1. There is identity element that is 1. So this is a monoid and this multiplication is associative. You already know that this multiplication is associative and also this structure is closed. This set of integers comma multiplication, this structure is closed also. This structure, correct? Okay, so this is associative also and this structure is closed also. So finally I can say that this structure is monoid. Now notice one interesting thing. In this structure, can I say, this is my question, in this structure, set of integers comma multiplication, okay, if a multiplied by b is equal to a multiplied by c, then can we do left cancellation? Then can I say b equal to c? Tell me, think about it. In this structure, do we have left cancellation? If we have this, then can we do left cancellation? Can we do left cancellation here? Think about it. Can we do left cancellation here? The answer is clearly no. The answer is no. Why the answer is no? You can again very clearly see that. Okay, just see, this is fine. For example, 5 into 6 is equal to, okay, 5 into b. From here I can say b equal to 6. That is fine. That is fine. Okay, that is fine. But you cannot always do this. You cannot always do this. This is fine. One example is fine. But I am asking, can you always do this? Can you always do this? This is my question. I am not asking for particular example. Tell me, can we always do this? So you can notice in this is your structure, set of integers comma multiplication. This is monoid. If we have this type of situation, can we cancel? Can we cancel on the left? Can we do the left cancellation? Can we say b equal to c? So the answer is no. The answer is, let me tell you, okay. So the answer is no. And why the answer is no? Because you can clearly see, notice that 5 multiplied by 0, this is equal to 6 multiplied by 0, right? Okay, so can we do the left cancellation from here? From here you can, but 5 is not equal to 6. So you can notice that you cannot do the right cancellation. So this is about, so no right cancellation. So no right cancellation. We don't have right cancellation, correct? So there is no right cancellation. And similarly, 0 multiplied by 10 is equal to 0 multiplied by 5. But you can notice that, but it does not mean that 10 is equal to 5. But 10 is not equal to 5. So you cannot do the left cancellation. Agree? Anyone has any doubt? So there is no left cancellation. Okay, is this clear to everyone? So this is the point. So this is a monoid and you can clearly see we don't have, so there is no left cancellation, there is no right cancellation. So from today onwards, if you find this meme, like, okay, this type of meme, if you find, for example, 6 multiplied by 0 is equal to 7 multiplied by 0. So what can we do? We can cancel this. So 6 equal to 7. If you find this meme, then what you will comment? Okay, if you find this dumb meme, then what you should comment? You should comment that, okay, z equal to multiplication is a monoid. In monoid, left cancellation is not there. In monoid, left cancellation is not guaranteed. Is not guaranteed. Okay, so like this you can do. Okay, so that's the point. So remember, this type of meme you will find on internet many times. You will find this meme. Now you know what is the actual reason. Okay, if anyone asks you like why we cannot do this, why we cannot do this, then you can simply say that this is a monoid, and in a monoid the left cancellation is not guaranteed, right cancellation is not guaranteed. Okay, the same thing I can say. So basically I can say right cancellation is not guaranteed, left cancellation, right cancellation, these things are not guaranteed in this monoid.